Hi everyone, I'm Wei Ling and currently I'm a final year actuarial studies student. And today I've been tasked with two questions on my computer-based test on our stochastic calculus for financial economics module. So today I'll be explaining on two questions. So first up, we'll look at question one. So question one is on Asian options, and okay, so this is a European style Asian option because it has been mentioned that exercise is only permitted on the expiry date. So basically, we are given a bunch of numbers here, and these bunch of numbers are actually randomly generated numbers, which is in the interval of 0 to 1. So basically, what we'll have to do at the beginning is that, okay, we are given these numbers. Okay, these random numbers. And then what we are supposed to do is that we have to look for these numbers on the standard normal table. And then we will compute these later on in Excel, but then I have written down a few of them first just to show everyone how we obtain the values. Okay. All right. Okay, then it goes on for all the 48 numbers given in the question here. So before we move into what is Asian option and how do we calculate Asian option, so we'll just break down the basics first on how we want to calculate the stock price for each month. So given that in question 2.1, a 48-month Asian average strike call option on cooperative food stock uses an arithmetic average based on the stock price at the end of each of the 1 month. So basically, we can note that each period is denoted by 1 month. So that is 48 months. So the usual formula that we use to calculate the stock price is ST equals to the stock price at time 1, which is multiplied by the exponential of R minus delta minus 0.5 sigma square, whole thing multiplied by T plus sigma square root T times Z. Okay, this Z here is where we are going to input our values obtained from here previously, the 48 numbers. Okay, so before that, we have to establish a concept where the stock price for each period is obtained from the stock price of the previous period. So basically, our timeline is 1/12, 2/12, all the way up to 48/12, which is 4 years. Okay, which is 4 years. So to obtain the stock price at this point here, as let's say T1, I'll denote as T1 and as T2. The stock price is obtained depending on the stock price of this period here, according to the formula we've established above. According to the formula here. Okay, so basically we can see that it's a recurring pattern. This is ST48. It goes on. So from previous period all the way back to S0. So ST1 will depend on S0, ST2 will depend on ST1. Okay, so before moving on to our calculations on the Excel sheet, so basically we will compute T1 based on S0 exponential R minus delta with the values already given in the question. So basically this will be Z1. and I will label this here, this number here as Z1, as it is the first number we will be using to generate our stock price in ST1, and this will be Z2, where we will be generating ST2 based on ST1 exponential plus sigma T Z2. Okay, so once we've generated all the numbers up until ST48, we will address what is the arithmetic average as mentioned in the question. So for question 1, arithmetic average basically means Asian average strike call option basically means that our payoff will be ST minus AT, which is the average strike of the stock. Okay, so given that AT is derived by its mean. So basically we sum up all our stock prices that we've calculated previously, and we get the average of it. So once we get this average here, once we get AT, we will insert it back to this payoff here. Okay, so right now, okay, before that, let's establish the one last point on how we calculate the option price for this question is that after we get the payoff, so we want to know the option of the price at time 0. So for this part is a call option. So we want to know the price at time 0. So we have to multiply, we have to discount it back to the original, to time 0. Okay, so now I'll show you guys on Excel on how to compute this question using Excel. Oh, and before that, I think I'll mention as well for question 2, the geometric average price put payoff is defined as K minus GT. Which is K is your strike price and GT is your geometric average of price put, which can be obtained by multiplying all your stock prices that you found for the 48 periods and find the root of it. So that's how we get GT. Okay. So as we can see here, this is question 2. So we've already moved all the numbers from the question to the Excel sheet here. And then by using the inverse of normal, we will get the Z scores for the random numbers generated. Okay, so using the formula just now, we define ST, which is the stock price at time 0. And then as you can see moving on, we used the stock price at time 0 to generate the stock price at time 1. And moving on, at time 2, we use stock price of time 1 to generate the stock price of time 2 by using the second z-score. And it goes on, moving on for the following numbers as well, up all until time 48 here. Okay, so addressing the first question and also the second question, we will find the average mean. So the average mean here is by taking the average of time 1 all the way up to time 48 of the stock price, and we get 59.96, while for the geometric mean, we use the function geomean to get the square root of 48, square root to the power of 48 for by multiplying all the STs into it. okay? And then, actually it's not square root, but then it's power to 1 over n. Yeah, my mistake there. But okay, so moving on, by using the formula just now we mentioned, because this is a call option for question 1, so the payoff would be maximum of the stock price S48 minus the average of that we've generated just now. And then we will get 5.29, and then the call price, we will discount it back to 4 years, because for the 8 months here, the given interest rate is for per annum, so we will use 4 years instead of 48 months. So that's how we get the call price. And moving on to the second question, where we'll be addressing the geometric average price put option. So basically we'll use the maximum function again, where the payoff is the strike price minus the geometric average price, and we will get 0 basically. And the put price, even after discounting it, it's just to show that we have to discount it back to time 0, but then the payoff is actually 0. Okay, now we will move on to question 7, the second question. Okay, so the second question is on exchange rate, which is a quite popular question. So one thing students always get confused with exchange rate is how we should look at it. So for this question here, it's basically a London-based fashion designer. Means we let's look at it in a perspective of that we are earning pounds, British pounds, while we are expecting to receive 100 million yen from a Japanese company as a payment for goods. And then we are given all the information here. Okay, firstly, we'll just look at the pound denominated perspective. Okay, pound denominated perspective means that our strike price, which is given by 0.0055 pounds per yen, while the current spot exchange rate is 0.005 per pounds per yen. And then the interest rate is 0.035. This is for pounds, by the way. And the foreign risk-free interest rate is 0.055, which is in yen. So from this, we can see that we are standing in a perspective of pounds. We look at it as in like we are earning pounds and the foreign currency is basically yen. So our perspective should be focused on how much we earn and how much we are going to lose in pounds rather in yen. So all the gains and losses should be looked in a perspective of pound. Okay, we should establish that clearly first. Okay, so basically now we have to determine if we want to buy a put or a call. So standing in the perspective of pound right now, and we are receiving 100 million yen. So we are going to hedge against the pound depreciation. So we are going to buy a put so that if the pound currency drops, I can still exercise the option of exchanging this much of pounds for the yen that I'm going to receive. Okay, so for this question here, we will have to use Excel as well because there's a lot of computing, but then I'll establish like the basic concepts here first. So in order to calculate we won't be using stock price here because the underlying asset here is actually the currency, but we will be using the same concept on how we apply for stock price. So how you calculate two ratios was the UD, U or D, basically I'll just write it in short form here. Use exponential of R minus the foreign currency, foreign risk-free interest rate times H plus minus sigma power H, sigma square root of H. So H basically here denotes your time period here. And then your time period here is basically they've mentioned by using a 12 period binomial tree. So basically you will have your H is basically yeah, your H, each of your H is basically for one. Yeah. Just that in total overall of your entire period, your H should sum up to the total of 12 period. Okay, so and then moving on, how you calculate the probability of it is exponential R minus RF power H minus D over U minus D. Okay, so basically, how do we use these two rows of formula is that from the binomial tree, we do know that, okay, you want to calculate for each period of what is your exchange rate is going to be. Let's say this is like the first period. First period, then we move on to the second period. Second period, you will have up, up, and also up, down. And then here we have up, down as well. And then right, let me just write properly, up, down as well. And this is down, down. So we will proceed with this up until square down. This as well. And then this is down twice. All right. And then this is D3. We will continue with this process up until for 12 periods. So your terminal period will consist of U squared, U12, U power, U, sorry, okay, U power 12. And then the next one is U power 11D. And then U power 10D square. As you can see, like there's a pattern all the way up to U square D10 and U D11 and also D12. So after establishing like this binomial tree here, okay, I will proceed explaining more on Excel itself so that it looks more clearer in that way. Okay, so okay, for question 7 here. Okay, so we look at this top part here first on the pound denominated calculation. So this is all the inputs that we've gotten from the question here. So basically H is 1 out of 12. So as I've mentioned, your entire period of your binomial tree has to be 12 months. So basically for one period is for H is 1/12. So the U, D, and P probability here is calculated from the formulas that we've established just now. Okay, and then so we will begin with by drawing out a table. So basically this establishes the from the perspective of the terminal price, terminal exchange rate, terminal time of the exchange rate, where you can see like this was actually what we've written in the last line of our binomial tree just now, which is U power 12, D power 0, U power 11, D power 1. Okay, and then we will calculate the stock exchange rate at time 1. So how do we calculate the exchange rate at time 1 is by using the general formula where we multiply the the spot exchange rate multiply by u to the power of 12, and then also multiplying by d to the power of 0. And we will continue doing that for the following numbers all the way up to u power 0 and d power 12. Okay, this is to calculate the exchange rate at time 1. And then moving on, we will calculate the payoff of the agreed the locked price, like the agreed exchange rate minus out with the exchange rate that we've calculated at time 1. So basically, we directly define a constraint whereby if the the exchange rate is greater than K, our payoff will be 0. However, if it fulfills the constraint here where it's a positive number, then the payoffs will be as follows, as you can see. Okay, and then next up, we will calculate the probability of exercising this option here. So basically, the probability of exercising this option is also derived from the original equation of calculating a put option. So basically, from the line of the put option, from the calculation of the put option, we can see that actually as you include the prices of the put option from times ahead into time 1, you can see like there's a pattern there where we keep multiplying the probabilities from further periods to get the put price at time 1, basically. So when we actually factorize them all out, you can see that basically it's just the probability multiplied by power of is placed to the power of 12 multiplied by 1 minus the probability to the power of d, which is 0 here. And it goes on all the way up to the bottom as well. And as for the combination here, so is basically, okay, I'll go back to the whiteboard. Basically, you can see just now is that, let's say we want to get U3. So basically, U3 is just, there's only just one pathway to get U3 here, right? Okay, so let's say we want to get U square D. There's a lot of pathways to get to U square D. So it will be, maybe you can go this way, and then we can go this way as well. And then we can go this way as well. Oh, no, sorry. Yeah, or maybe we can go, hold on, we can maybe go this way. So there's like three ways to get U square D. So when we establish the same concept to at time period 12, right? Time 12 here. So how we get the combinations on how many ways to get to like the terminal payoff for that particular combination there is basically, let's say we look at time 3 here, time 3. So it will be 3 factorial divided by 2 factorial, that is u, and also 1 factorial of d. And that goes on the same thing for all the numbers all the way up to d3. So as for d3 is just 3 factorial, and then is 0 factorial, and then 3 factorial. Okay, and we will do the same thing for time 12. Okay, doing the same thing for all the way up to time 12, we can compute this using Excel. Yeah, so for this, you can see is a factorial of 12 divided by 11 factorial times 1 factorial. Okay, then moving on, we will multiply the probability and then also the combination on the number of ways of it happening, of us exercising the option. Okay, so, and finally, we'll multiply it by the payoff, and we will sum up everything to get the payoff. But then we will have to discount this all the way all the way to time 0. So we will discount it by 1 period. So we are discounting it by only 1 year and not 12 months. So as the rate here given is per annum, so we will discount it by 1 period to get the put price. This is just for a single unit of 0.00059, and we multiply it by our initial cost of hedge, which is 100 million yen. Okay, so for this question, we will also be using the yen denominated method to calculate our cost of hedging. So as for yen denominated, we will have to convert the spot exchange rate and also the strike price by dividing the 1 over the pound currency here. So we get it in terms of yen. Okay, everything, all the concepts here are the same, except for that in yen denominated, we will be buying a call because we will want to hedge against the appreciation of yen, which is like the direct opposite perspective of calculating it in terms of dollars. So as you can see, we'll be using the same procedures as we calculated using a pound just now to calculate the probability, the combination, and also multiplying the probability times combination, and then also the payoff as well. So, and then we sum them up, and then we get the call price, and then moving on, we discount it back to time period 1. And then, however, for the cost of hedge here, we will have to multiply it by 100,000 yen. However, we will have to divide it by our newly defined strike price here by dividing it by 181.82 yen. As for the okay, so that's how we get like the cost of hedging in terms of like dollar denominated or yen denominated. Okay, so moving on to the second question. So the second question basically asks us to calculate it using the Monte Carlo simulation by using 200,000 iterations. So the 200,000, we will be calculating it using the pound denominated perspective. So we use like the sequence to generate sorry, it was 100,000 iterations, okay, to generate 100,000 numbers of random numbers, and then we input it into the formula of by using the initial spot exchange rate for every period to get the exchange rate for every period as well. So from that, after that, we can calculate the payoff of put, the payoff put. So by using the formula, maximum payoff of the strike price minus the spot exchange rate. And by that, after that, we find the average payoff of all the 100,000 iterations, and then to get the expected payoff, and we will discount it back to 1 year as well. And however, we also have to note that this option price is for a single unit, and after this, we will multiply it to the power of for 100 million yen as well, just to get the option price. So that's all for my video today. Thank you.